when they're designing different things. So here we have an eel, and they're tracking movement of the eel and using something called computational fluid dynamics, which is called, or CFD for short, which is a fancy way of saying a modeling software that takes the motion of this eel and allows engineers to modify it and analyze it to see what changes they can make to make it move faster or slower, and then use that in their design for whatever they're making.
So how many of you guys swim? Yeah, do you know what the dolphin kick is? So we came up with that because we're mimicking nature. Dolphins are natural swimmers. They know what's right. They know what's good. So we like to copy them, and we can use fluid dynamics, and our body is in the fluid, so we can, engineers look at that to make sure we know what works right and what doesn't. And another way engineers can actually conquer this is, so this swimsuit is called the Speedo LZR, and engineers developed this by using special material to make the suit itself more buoyant so that the swimmer is more buoyant, and they also use material to shape the actual body of the swimmer so that you're the most aerodynamic and have the least drag. And actually these swimsuits were so effective that in the 2008 Beijing Olympics, after they were used, they were banned because it gave the swimmer such an unfair advantage.
Such an unfair advantage that 23 out of the 25 World Cup records were broken by these swimsuits. So that covers water. Now we're going to talk about dynamics in air. So can anybody give me examples of technology that moves in the air? Drones, right? Another one? Hot air balloon, yeah.
Yeah, killing it.
Helicopters as well. Oh, there's a few more.
Just things in air.
All right. Skyscrapers. Just think about that one. Soccer balls, baseballs, basketballs, golf balls, and cars. Cars are also affected by air and aerodynamics. So engineers, again, will go back to nature to understand how things work. And so here we have a hummingbird, and they're analyzing the hummingbird's flapping movements to actually develop micro helicopters and other small aircraft that so they can make them faster and more efficient. So airplanes, aeronautical engineers, when they're designing them, the entire thing is immersed in air. You don't see air, so it's kind of, sometimes you forget that you're really swimming in air when you're in a plane. So the wings are one of the most important parts of the airplane when it comes to keeping them in the air. And that's because if they're designed incorrectly, they can create a lot of drag, which slows the plane down, and also turbulence, which creates the vortices that we see in the back. So what engineers need to do is they need to design them to reduce these effects, or negative effects, and while maintaining lift, so that the plane stays in the air.
So let's take a look at the cyclist. You can see that his helmet is shaped a little funny, and he's kind of hunched over. Do you guys know why? Yeah?
So the air can flow over him.
Exactly. He wants to create as little drag as possible, so he wants to make sure he's really condensed so that air can just flow right over him instead of stopping him. And it's also kind of funny to think about buildings when we're thinking about air, because we don't really think that they interact that much, but have you ever walked by a really tall building and you're turning a corner and then you get hit with this huge gust of wind? It's because the air in the building are all interacting, and this fluid dynamics creates these air vortexes that are really interesting to study for engineers. Another reason why engineers want to study fluid dynamics is because their forces are actually really powerful, and if we don't pay attention, and if we're not careful when we're designing something like a bridge that interacts with the air, we can have really big disasters. One small design flaw can lead to something as big as this.
So that was just caused because the wind was blowing too strong that day, basically. So that's things moving in air. Now we are going to talk quickly about how the design of sailboats has changed from pirate ship era to modern day racing. So old sailboats, they really only moved in one direction. Why? Because their sails were fixed. They could only really move in the direction that the sails were facing. So modern day sailboats, they allow them to turn the sail so they can catch the wind in different directions, and also they have a keel underneath, which then they can turn, and they can use that to change their direction so that they can move in almost every direction except for right against the wind. So here we have a catamaran being used in racing, and they also have, they're especially designed to stay as much of outside the water as possible so that they reduce the amount of drag. So overall, we talked about the fluid concepts. We talked about viscosity, buoyancy, pressure. We talked about things moving in water, things moving in air, and we talked about sailboats.
Thank you for listening to our presentation, and before we move on to the hands-on activity, does anyone have any questions?
Anything at all? No? Everyone, good idea of how fluid dynamics works?
Nice, you're
Great,
experts now.
'cause now you're going to build your own sailboats, and you're going to test them on the little lakes that we've created in the back using our plastic tubs. So the first thing you guys are going to do is you're going to, like all engineers, you have a plan before you start building. So you're going to sketch it, then you're going to build it using the materials we have in the back. We will help you with all of that and getting the right materials. Then we will test them using the fans and the pools of water. And then once testing's complete, they'll race against other people.
Yeah.
So
You guys
we're going
can
to start
work in
handing everything
groups
out
and-
and have fun with it.